Okay, we continue. We have said that without other information background from the historical recording of 2016, we would see an average American will have likely the similar likelihood to vote to both parties. So we need one bit of information to describe his or her decision without any prior knowledge. Then let's see how about instead of looking at the entire population of American, we select a subpopulation from this entire population and see if things will get more informative. For example, we can select a population. Well, pandas as a library provides us a super convenient way to select population, a subpopulation from the entire. It is like you select a filter criteria in Excel spreadsheet and select only certain rows. So this is a binary condition. Says okay, if the record is within California, then this row will be marked, and you do the mark in the selected part, and then it will be true false binary mark, and use this mark as mask to select particular rows in this. Let's have a look at what we will have. Okay, you still have a view of, which means a filtered subset of the data frame, which is the table. Look, but you do not have every row of the table. You only keep all the rows that belongs to California. So in this subpopulation, we repeat whatever computation we've done above and see what we'll have. So because the computation is largely repeated, so I'd rather to summarize it into a function, which I call that exam, the votes. Basically, I just do whatever we have done before, and but with the data frame as an input. Look, you give me this table, and I will do the computation using the table you given to me. Okay, that is the interested table. I deliberately call that interested data frame. I define that, and I will call this using the selected part of the data table. And let's see what we have. Okay, those print function is within here. So within California, you have votes for Democrats largely exceeding that for Republicans, and entropy reduced, which means if you try to record all the ballots in California in 2016, the minimum file size you will have will not be the same as the total number of the ballots. You can save some, you can compress the information by the prior knowledge of that. You know there are more Democrats votes than the Republican votes. For example, you can cleverly design a scheme such as why not use 1 to represent Democrats, and so whenever I encounter 1, I will interpret that as 2 Democrats, and then if I encounter 0, I will examine the next bit. If it's 0, 1, I will decompress that as okay, maybe we have a Republican vote, so on and so forth. So anyway, using the knowledge that there are more Democrats than Republicans, you reduce the uncertainty, and you can pass more information use the same number of bits, or you can pass the same amount of information use less number of bits. So that is the information theory tell us. Okay, so we have a very intuitive view of the entropy and how it corresponds to the uncertainty of the vote in a population or in a subpopulation. Okay, so in the next step, we will do a bit more automatic investigation of the task and try to formulate some predictive task and see how we can apply the knowledge of the information theoretic computation. But before that, to form some general idea, let's have a look at the data visually. So I will use the Plotly Express as a visualization and show the data on a scatter plot. But this is a geoscatter plot. Let's look. It takes a bit time, and I color the dots using the Republicans, proportion of Republicans in 2016. Well, there are a lot of points, so we will need a little bit of time to get it rendered on my let's get it see if I can so when you are doing this kind, you can select subset of the data to show when the computer is not super fast, and also you can specify the range of the geographic area to show a particular part that is most interesting to you. Okay, so anyway, this plot shows the votes in different places, because those data also include the location of the counties and the population. So look at here. I render the dots using the total number of votes in each place, and the color is according to the percentage of the votes received by Republicans in 2016. Okay, well, at least this scatter plot shows us there is some trends, there is some tendencies to be discovered in the distribution of the data. So at least, for example, we can see it seems that the population size is related to how many votes the Republicans can receive. Okay, and there are a lot of different measures. Maybe in the next we see a little bit more. I think I will fold this one to accelerate the processing a little bit. Oh no, yeah. Okay, now it's gets faster. So okay, this is not very informative. This is Republicans against the Democrats. Of course, they need to add to some total number of nearly 100%, and it shows some county names here. Okay. So before we go, let's have a look at some extreme cases. Say this single place is mostly extreme vote result, has the most extreme vote result. Republicans received only 4% of the votes, and let's see our uncertainty measure in this subpopulation. Okay. Here. Oh, it's DC, of course. Oh, the entropy is so small. That means we can almost use one bit to encode 5 balers in this place. Okay, so let's move on and to try to formulate some predictive task and get some primary primitive attempt.